Hey, what's up YouTube? It's me, George, and in this video I'm going to be discussing the Tanimoto coefficient. Before we begin, it's important to recognize how many compounds are available for research in databases. So according to PubChem in April of 2018, there are over 95 million indexed compounds. Let's say that a drug company was interested in looking more into the chemical-physical properties of a molecule that may be incorporated in a future drug for alleviating pain. It wouldn't be very practical for that drug company to go through all 95 million compounds in order to understand, or in order to identify molecules which may be of interest in the lab. So that's where indices like the Tanimoto coefficient come into play. The Tanimoto coefficient is essentially a numerical value which is representative of how closely two molecules are related. To understand the equation for the Tanimoto coefficient I put on the screen, I've created sort of an example problem. So let's say we're trying to compare two molecules, molecule A and molecule B. Molecule A is a hydrogen bond donor, aromatic and amphipathic, and molecule B is a hydrogen bond donor, amphipathic, non-aromatic, and linear. The N of C refers to how many parameters are common between the two molecules. So they're both hydrogen bond donors and amphipathic, so N of C is 2. N of A refers to how many individual parameters each molecule A has. So there are 3 descriptors, so N of A is 3. For molecule B, N of B is the same thing. We can see, according to the Tanimoto equation, these two molecules have an Tanimoto coefficient of 0.4. Some drug companies may indicate that they are only going to research compounds for a painkiller. Let's say that they use morphine as the molecule they want to compare with all 95 million compounds. A drug company might say that they're only going to compare or look into compounds with a Tanimoto coefficient of 0.85 whenever compared to morphine. And that would literally eliminate tens of millions of compounds with different chemical-physical properties with very low likelihood of producing the physiological response that they wish to provide from their drug. So obviously this isn't done by hand. Even in databases you can search for molecules according to particular parameters. And doing these searches this way allows for a much more systematic and efficient approach for identifying compounds with similar physical properties. So here's the exact example of somebody looking up compounds with Tanimoto coefficients of morphine. Codeine, heroin, and methadone all produce similar physiological responses of morphine. They're all painkillers. And we can see codeine and heroin have very, very high Tanimoto coefficients, as the maximum is 1 to morphine. However, methadone is structurally very different than morphine and only has a 0.2 Tanimoto coefficient. So a Tanimoto coefficient really shouldn't be dogma in determining whether or not a molecule or compound will produce the particular physiological response. So that's it for the Tanimoto coefficient. If you have any questions, comments, or concerns, feel free to email us at nocopaytutorials@gmail.com. Thank you.